In this video, we are going to talk about the IUPAC nomenclature of polyspiro compounds. In a previous video, we spoke about the IUPAC nomenclature of monospiro compounds, but how to arrive at an IUPAC name if a molecule has multiple number of spiro centers. What I mean is, let us say you have a compound like this. So in this case, we have one quaternary carbon here, the 4-degree carbon we call it, and then we have another quaternary carbon here. So this is basically a dispiro compound. So how to arrive at an IUPAC name for this molecule? The rules are same as before, and few additional points that you need to keep it in mind are as follows. Pick the terminal cyclic ring that is the smallest. In this case, obviously the 3-membered ring is the smallest, and start numbering from there. Okay, so and we know that we have to start adjacent to the quaternary carbon. So let's start from here. 1, 2, 3. You can go either side in this case because both are going to give similar results. So 4, and then 5, 6, 7, 8, 9, 10. And now the second point that you need to keep it in mind is, give spiro atoms as low numbers as possible. We will discuss one example specific to that, but let us first work on this example first. Okay. So, and then the third point that you need to keep it in mind is, now in the monospiro case, we had a name like your secondary prefix is spiro, and then xy, and then parent chain. So in this case, what is going to happen is, here it's going to be like dispiro, okay, and then x1, x2, y1, y2, and then we will have some numbers as superscripts. Okay, so that's the position of the spiro centers should be written as superscripts, and then the parent chain. So keeping these things in mind, let's work out the IUPAC name for this molecule. So for this compound, it is dispiro. No substituents are there, so dispiro. Okay, and then what is the value of x1? The value of x1 is these two carbons. So x1 is equal to 2. Okay, you have 2 carbons there, and the value of x2 is this one. So x2 is 1. So 1, and then value of y1 is these 4 carbons. Okay, and then the value of y2 is this 1 carbon. So 2, 1, 2.1, and then 4, and then 1 again, and then close the bracket. So total we have 10 carbons. So that means it's a decane. Now in addition to that, we need to mention the position of the spiro carbons, the quaternary carbons, where the quaternary carbons are there, that position we need to mention as superscripts at the place of y1 and y2. So where is y1? y1 is starts at 5, ends at 5. So that number you need to write it as a superscript. Okay, and then where is for the y2, where is it? It is at joining at 3. So that number you need to keep. So the correct IUPAC name for this is dispiro, and then open the square brackets, 2.1.4, not to the power of 5 as superscript on superscript 5 and then dot 1 and then superscript 3, then close the bracket and then decane. So that's the correct IUPAC name for this molecule. So let's discuss one more point, the second example where the second point that I mentioned, like give Spiro's atoms as low numbers as possible, will become very obvious. So let's say we have a system like this. Now the terminal carbons are 4-membered rings, so you can start the numbering from anywhere. But then in between we have a double bond. So we need to be careful here how we are numbering. So we will number it in 2 different ways. So let's say this is 1, 2. So that's our terminal carbon. Sorry, the terminal ring. So 1, 2, 3, 4. Now the question comes: should I go down or should I mention the alkene at 5, or should I just start continuing like this? So there are 2 possibilities, right? 6, 7, 8, 9, 10, 11. So that is one possibility. The other possibility is 1, 2, 3, 4 and then 5, 6, 7, 8, 9, 10, 11. So which one is correct? So as I mentioned before, here the position of the Spiro centers are at 4 and 6, whereas here the position of the Spiro centers are at 4 and 7. Which gives low numbers? Obviously this gives low numbers. So therefore this is the correct way of numbering. So if we number it on the other way around, then this is a wrong way of numbering. Okay. So therefore the correct IUPAC name for this molecule is Dispiro. So in X1 how many carbons are there? We have 3 carbon atoms. So 3, and then your value of X2 is this 1 carbon atom. Okay, so this is X1 is 3, X2 is 1, so 3.1, and then once again you have 3 carbons here. That's your value of Y1, 3, and then the value of Y2 is 2. So 3.1.3.2, close the bracket. Now you need to mention the position of the quaternary carbons. So when you are coming to 3, so this 3, the second 3, that is at position 6. So that you need to mention first as superscript. And then these 2 carbons are at where it is ending? It is ending at 4. So that you need to mention it. So total 11 carbons are there. So it is a undecane, but we have a double bond. So therefore undec. So it will be undecene, not decane. So undec, and then the position of the double bond is at 10, undec 10 ene. So that's the correct IUPAC name. Now you can also give a name for this. So let's for the wrong way of numbering. So we let us work out the IUPAC name for this also. So this will be Dispiro, and then 3.2 because we came this side. So this is X1 is same. Now your value of X2 is changing because we came this side. Okay, 3.2, and then value of Y1 is 3 again, and then the value of Y2 is 1. So 3.2.3.1. So here you will be mentioning that these 3 carbons are at position 7 okay, when you go from this side of the ring to the other one, and then for 1 you are at 4. So this one y2, the value of y2, where it ends, it joins at 4. So that you are mentioning. And then undec or undec, whichever the way you want to call it, 5 in. Now the problem here is, you might be thinking that, you know, I gave low number for the alkene, so alkene should get the lowest locant. No, that's not correct. The Spiro atom should get as low number as possible, okay, and therefore this is the name that is correct for this example, okay. So now I will show you one more structure. So if you do find IUPAC name for this, please write it as a comment. So that's your homework, okay. Yeah, so if you do like this video, consider subscribing to Chem Media. Thank you.